Good evening and welcome to this webinar on how to ace number properties. In this webinar, we're going to focus on that one topic of LCM and GCD. And my goal with this webinar would be to make sure that we look at, sorry, not LCM and GCD, divisibility and remainders. And my goal with this webinar will be to look at a simple concept in divisibility and remainders, and then using that concept help you solve the easiest or the most challenging questions. We will not do a lot of complex math, but we will solve questions that are probably the most challenging questions that the test would throw at you. So if you're aiming for a Q50, Q51, you'd be able to solve those questions regardless of the fact whether you're at a Q30 right now or at a Q45 or at a Q49. So fairly application focused webinar, fairly intense webinar today. And you need just a few basic set of concepts that you need to know. The concepts that you needed to know were sent over to you in these two video lessons, prime numbers 1 and prime numbers 2. If you've not gone through these video lessons, go through them post this webinar. They are a part of your free trial. And once you go through them, you'll have that foundation. And so anything that you feel that you're still missing after this webinar, it'll be completed once you go through these video lessons. We also have some upcoming webinars. We have two which are in the next 7 days. One is a free webinar on GMAT reading comprehension. In this webinar, we address some of the myths that people have around GMAT RC, and we'll look at how, if you follow some key reading strategies, you can improve comprehension and B, consequently aids GMAT RC in as few as 10 days. And when we say 10 days, we're talking about 30 to 35 hours of effort. The second is a quant workshop. Think of that quant workshop as a proctored mock test. For those of you who want to build a study plan that gives you an entire that helps you visualize how you would get to a certain quant score, this workshop diagnoses where you currently are, tells you why you're faltering or which good habits do you need to inculcate, and then helps you create that personalized study plan to get there. It actually uses our neural network technology to build some of those insights. So again, both these sessions free, both these sessions very heavily attended. Register for them, make sure you put time on your calendar for them. Since this is a free session, we do kind of like to understand the makeup of this group. I'm going to ask a couple of leading questions. One is, when do you plan to take the test? The second is, where do you currently are in your quant preparation? And you see different buckets over here. And the third one is, what is your target quant score? All right. Let's get good answers. So when do people plan to take the GMAT? About 34% of you who haven't taken a date as of yet. It's the biggest segment. And then another 23% of you in 46 to 75 days. A surprising 25% of you have your GMAT right away. We want to make sure that we help you guys because time's precious for you. And then the next two groups, but the smallest group in 16 to 30 days, and then 31 to 45 days. So this first question, actually, the number of people in this 15-day group makes me curious. So how many of you who are taking the GMAT in the next 15 days are planning to send your updated scores? I've already applied in round 2 and are planning to send your updated scores to business schools. So how many of you are taking the GMAT in the next 15 days are those who are planning to do this? I've already applied and are hoping to improve your score, so to increase your chances of admission. So, okay, 2, 3, 4. Okay, that's very smart. For those of you who don't know what I'm talking about, in USB school especially, you can update your GMAT score between the time you apply to the school and before you hear back on a decision from the school. So I mean, if these people have already applied and if there's yet to hear about an interview decision, then this is something that's very smart of them. We've had many students who got waitlisted in R2 actually, so they didn't get a reject, updated their GMAT score, not only received admits, but also scholarships overall. So that's very smart. With regards to the current quant scores, big chunk of folks less than 40, a good chunk of people in the 46 to 48, greater than 48 group over here. With regards to target quant score, 75% of you are in the 50-51 bucket, and very few want to target the 43 to 46. So that's great. Thank you very much. With that, let's go into the presentation pane. So we are now in the presentation pane. I'm going to give the system another 25-30 seconds for it to settle down. So what we want to do in this webinar is I want to show you 3 questions that I want to make sure that you guys get absolutely correct. Now these are 700 level questions, and so I'm going to have you attempt these questions once right now. I'm going to give you about 2 minutes to attempt them. Some of you would get it right. There'll be many who won't get it right. These are 700 level questions, and then we're going to go through this webinar with the ultimate aim of being able to solve these questions. So so let's do that. Let's get to this. I want to start from the right slide, since many of you are taking the GMAT right away. Let's just start from this slide over here. So what I want to achieve in this session, I want to achieve 2 things. One is that that you guys understand what does it take to is GMAT Quant. GMAT Quant isn't as much about math as it is about logical reasoning, and so that's something that I want to make sure that you take away from this session. The second is if you have a method to solve questions, not tricks, but a method to solve questions, you can actually solve the most challenging questions. A third thing, which is kind of a corollary out of this, is that when you make mistakes not because you don't know the math, but you make mistakes because you actually have inculcated certain bad habits that kind of force you to take your thinking or take your calculation in a certain direction, and that's where you make a mistake, and we want to make sure we avoid those habits. So once again, what would be the layout of this? I'm going to give you these 3 data sufficiency questions, 700 level. And that's something which is what our goal would be, that we are able to do this. Each one of you is able to do this by the end of this webinar by yourself. Okay, but this is kind of what our holy grail for today. And once you take a look at this, take a stab at this without the learning from this webinar, then we're going to start the learning, which is going to be from this warm-up piece over here. Then in the warm-up piece, we're going to brush up a bit of foundation. Then we're going to go to some problem solving questions. This will be 650 to 700. Then we'll go on to 700 level problem solving questions. And then we're going to be right back at this set of questions, which is essentially nothing but this set of questions again. And you'd see that you'd be able to solve those questions. This entire process, about 90 minutes to 100 minutes overall. I think Jalpa or Halpa, howsoever you pronounce your name. So about 100 minutes or so is what it will take us, but we'll have a lot of fun during this time. There'll be lots and lots of back and forth. I'll look forward to hearing your questions, and as well as my co-host. His name is Sandeep. He's a quant SME. He's one of the smartest quant guys that we have. I look forward to hearing your questions in the Q&A pod, and essentially addressing those doubts. So once again, 3 questions, 700 level. We call these Q8 to Q10. You'll see the polls would be numbered as well. Then we'll get to the warm-up stage. We're going to solve about 5 questions, less than 650 levels. These are foundational questions, basics. This is where if you're rusty with the basics, we want to make sure that we kind of imbibe those basics in you. Then we get to the problem solving part, 650 to 700 level. Again, we're going to start applying these basics. We're going to get you, again, the next level of warming up is what I call this part. 3 questions. Then we're going to go to 700 level, but problem solving questions. Going to solve about 4 questions here, and then come back to Q8 to Q10 once again. So are you guys ready? I'm going to actually put in a poll question. Let me just minimize the Q&A pod over here. And being ready means you should have a pen and paper ready with you. You should also probably have a bottle of water or a glass of water like I do, um, with you right then and there. So one other piece. So is the thank you for that feedback. That's really great. Then is the presentation clear? I mean, and is that actually taking a big chunk of the screen so you can read the font on the presentation? All right, that's really good to know. Perfect. So what I'm going to do is we're going to start with our first question. It's called question number 8, and I'm going to remove my video now. And what I want you to select is still solving. That way I know how many of you are solving this question. So there's a choice which is beyond choice E, which says still solving. And I want at least 40 people to select still solving. So that way I don't time you guys as a group. You guys time yourself as a group. But again, for the first 3 questions for now, I'm going to give you um, but 2 minutes per question because you're going to solve these questions once again. All right, perfect. I'm going to remove broadcast results. So you guys can't see each other's answers. Here is the first question, question number 8. You should be seeing it now on your screen. Okay, about 60% of the class is done. All right, 3, 2, and 1. Get those answers in. Perfect. Let me end the poll. And I'm going to broadcast the results. You guys can really see pretty much everyone was done. Choice A was very popular. Choice C, next most popular choice. And then the other choices didn't get as much love. I'm going to hide this. We're going to go to the next question, question number 9. You can see the poll over here. I want you to follow the same exercise, still solving. And I want to get 40 odd people over here and still solving. And again, we're going to discuss these questions in detail towards the last part of the session. This is where we want to get to, that each one of you should be able to answer these questions successfully. Perfect. So I'm going to remove broadcast results, and here is the next question. You should be Okay, but 70% of the class is done at this point. I'm going to give you another. Get those answers in, guys. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and you can really see a few more choices that got more love. Choice A, it was still the most popular choice even for this question. You know, everyone wants to be right out there. Choice is popular, choice C is popular, so is choice D and choice E. So we're going to really see this. This is starting to get a bit more fun. Then we are now going to go on question number 10. Again, still solving. Let's get there. So 24, good. 30. Let's get to 40 people to select still solving. 40. I'm going to remove broadcast results. You should be seeing questions. All right, guys, 60% of the class is done. So another 25, 30 seconds is what I will give you. Right, most of you were done. That's wonderful. That is good. Let me end the poll. 3, 2, 1. I'm going to broadcast the results. And again, in this we got more of a split jury. That is great. Choice A was popular, B was popular, so was C. D was rarely popular, and E also got some love. And a few people were still solving, so that's wonderful. So we're gonna hold this, and then let me bring my video back. So for those of you who joined in the last 8 or 9 minutes or so, we didn't start any learning as of yet. What we did was we solved 3 questions. These are the 3 questions that we do intend to solve once we go through the learning. And so I want to first of all thank you guys for enthusiastically selecting not answered. It just makes things easier. It just saves time for everyone. But these are the three questions that we want to make sure each one of you is able to answer, and not just answer, but is able to answer naturally by the end of this webinar. Okay, so this was just where we want to get to. Now let's start the learning. We're going to start with the warm-up section. Let me actually get my polls ready over here. And in this warm-up section, what we're going to do is we're going to solve a few questions and just very foundational questions. This is what we call as 500 to 600 level questions, and we're going to solve them. And just to make sure that you guys still remember the basics. So for some of you, that'd be very easy. For others, you'll have to jog your memory if you've not studied divisibility and remainders at all till now. You'll have to jog your memory, but for most of you, it should be fairly simple. If it's not, once we actually show you a couple of solutions, it will become fairly simple. So still solving. Let's get a few more folks to select that. And then and the first few questions will only have 3 answer choices, so don't choose choice D by any chance. The third question onwards, we're going to have 4 answer choices. So I'm going to remove broadcast results. Here is your first question. As the first question, the class is done. Let's get those responses. 3, 2, and 1. Let me end the poll. Let me broadcast the results. 70% of you got it right. It is Z is always divisible by 3. Now, there are a couple of ways in which people could do this. One is you just plug in numbers and you do this. That's not how I want you to do this. Why? Because this is a foundation building question. I want to make sure you understand why this happens for every pair of 3 numbers. Why? Because we're going to use the same foundation as questions get more difficult. So the divisibility rule for 3 years is the sum of digits should be divisible by 3. That's kind of the concept that we are testing over here, which is hey, sum of digits should be divisible by 3. That's the only thing that you need to know. So what's the sum of digits of Z? Let's assume, because Z is built up of 3 consecutive numbers, let's call those numbers x plus 1, and x plus 2. You add these numbers up, they become 3x plus 3. You can take 3 common over here, and it becomes 3 times a number, and, and then 3 times a number is always divisible by 3. That's basically what there is to it. So fairly simple. Okay, for those of you who are saying maybe divisible by 3, that the key thing over here is to remember that for a number to be divisible by 3, sum of its digits should be divisible by 3. Okay. So with that, let's move forward. I'm going to I'm going to show the next question, but before that, let's kind of get back to still solving. And if the faster we do that, the faster we move on to the next question. 35. Let's get to 40. 3, 2, and 1. I'm going to pause my video now. And here is your remove broadcast results. And here is your next question. Here's the next question. All right, 80% of the class is done, so let's get those answers in. 3, 2, and 1. I'm going to start my video once again. Let me end the poll and broadcast results. So two most popular choices, choice A and choice C. Choice A is the correct answer. Now, again, why did we have this question? Because we're talking about divisibility by 4, and we want to make sure you guys remember the rule for divisibility by 4. The rule for divisibility by 4 is that the last two digits of a number must be divisible by 4. So it's not the sum of digits, so we can't use the same method that we did for 3. We have to remember the divisibility rule for 4. So there are two cases. You could be odd, which means you could be 2, 3, 4, 5, 2,345. In this case, the last two digits clearly are not divisible by 4. The second case is z could be even. In that case, there's a possibility that the last two digits could be divisible by 4. Okay, so in the example is 3, 4, 5, 6. So it is possible that z can be divisible by 4. It is also possible that z may not be divisible by 4. And so the correct answer is choice A, that z may be divisible by 4. There's a possibility it may be divisible. There's also a possibility that it isn't divisible by 4. Okay, now we're going to go to the third warm-up question. So again, you see what we're trying to do over here. We're trying to just jog our rules with regards to the divisibility rules of various numbers, and that's the same theme that we're going to continue moving forward. So next questions, please select still solving. And again, I'm going to share this PDF. So if you want to revise some of this, you'll have the PDF as well. 3, 2, and 1. Let me remove broadcast results, and I'm going to share the next question. Here's the next question. All right, almost 80% of the class is done. Let's get those answers in. 3, 2, and 1. I'm going to end the poll. I'm going to broadcast the results. Again, you guys did really well. 72% of you got it right. The concept that we're testing over here is a divisibility rule of 8, which is that the last three digits should be divisible by 8. All you need to look at is these numbers, and you really say, hey, which one's closest to this and which one's divisible by 8. Or you could look at this number and say, man, if I take 1 minus or 1 positive, since it has to be an even number, and then divide by 8 over there. Okay. So again, do 897 by 8, it gives a remainder of 1, which means 896 is divisible. You choose that and you move forward. Again, divisibility rule of 8, last three digits should be divisible by 8. Now, next question, last two questions in this set. But again, you're seeing that the divisibility rules are what we are testing over here. And we want to, if you guys want to make some notes, if this is something that, it is not as fresh in your memory, you just may want to write this down, because we're going to apply this as we get to the next set of real questions. So again, if you guys can select still solving so that I can move on to the next question. 3, 2, and 1. I'm going to remove broadcast results pause my video, and here's your next question. Portion of the class is done. Let's get those answers in. 3, 2, and 1. Once again, you guys have done really well. 71% of you got the question absolutely right. In this question, we're gonna, in addition to using the divisibility rule of 4, we're also using what we call as a process skill, which is the skill is called visualization. Um, and 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 um, and so the concept that we're using is, hey, when you look at a number n, which is your dividend, it can be expressed as divisor multiplied by quotient plus remainder. So what this tells us is, if this number leaves a remainder 3 when divided by 204, so we can express n as as a factor of 204. And but what is the question asking us? The question is asking us what is the remainder that n leaves when it's divided by 4, which means n should be expressible as 4p plus r, where r is this remainder that we are looking for. And remember, a remainder always has to be less than the divisor. So what is n? N can be expressed as 204q plus 3, so a factor of 204q plus a remainder. And then as we compare this, we can express 204 in terms of 4. So that's what we do. We say 204 is 41 times 4 and then times q, which means that this part over here is completely divisible by 4. It doesn't leave any remainder. The remainder that's there is still 3, which gives us our correct choice as 3. Now, this skill over here, being able to express 204 in terms of 4, is what we call as visualization. Now, this may seem very simple right now, but as questions get more complex, we're going to use this skill again and again and again. All right. Actually, before we go on to question number 5, let's still, the last question of the Swarmer phase, let's still select still solving. I want to get to 40 people. That gives me enough of this group so that I can call time properly. All right, 44 people. Last question over here. Here's the last question. Let me pause my video. All right, guys, pretty much everyone is done. That is That is great. I'm going to give you another 5 seconds to put your answers in. 3, 2, and 1. You guys again did exceedingly well, but 70% of you got this right, or 68% to be more specific. It just shows you have the right foundation, and you should have gotten the DS questions right as well from a math standpoint. Again, we're using the same concept where dividend can be expressed as divisor times quotient plus remainder. Again, the same concept. We're going to use this concept again and again and again. And what do we need? We need to know what is the remainder that n leaves when it's divided by 5, which means n should be expressible as 5p plus r, and this r is what we are looking for. And remember this, that r must be less than 5. That's a constraint that you need to remember. So how can we express n in terms of the given information? N can be expressed as 205q plus 6, which again, if you visualize 205 in terms of 5, we can really write 205 as 5 times 41, and then that gives a remainder 6, which when you combine this, that since that part is completely divisible, we can express 6, which is the remainder over here, as 5 times 1 plus 1, which means when 6 is divided by 5, you get the remainder 1. Okay. So Ra says, if 205 leaves a remainder, it won't. Why? Because 205 multiplied by any number would always be divisible by 5, because 205 by itself has 5 in it. So in that case, Raz, we're going to see that example in the upcoming solutions. I'm going to leave this for another for another couple of seconds so that you guys can take a look at it. Okay, and now we're going to move forward. But this is something that we expected you guys. This is something that we expect you to know before you come into this session. This is the only foundation that you need, and the reason we did this warm up was because we want to make sure that you have 200% clarity in concepts. So if you scored less than 100% in any of these concepts, then I want to make sure that you revise these concepts. And again, they are a part of your free trial. So so you can easily revise them. But now we're going to move on to GMAT-like questions, which will use this application and take that application to that next level. So now you will have 5 answer choices. So let me swap my poll, and let's go over here. So select still solving, and so that we can go on to the real questions that we are here for today. So we did the 5 foundational questions. Now we're going to do 3 600 to 700 level questions. I'm going to remove broadcast results, and again we call them 650 to 700, but I think they're 600 to 700. So here is your first question. Guys, upwards of 70% of you have solved this. That's great. Let's let's get the answers in so that we can move forward. All right, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. So really good. I would say, accuracy over here, 62% is good. But the thing which was there was, till I called time, it was about 51%. So those of you who, the last 10% of you weren't very certain on how to go about getting to the answer. The concept that we're using, still the same concept, and we're going to kind of, harp upon this concept again and again. We want to make sure that you become champions of applying this concept. It's applied in a slightly more complex context. So what does the question say? The question says m is a positive integer a and m by 30 is this decimal 8.2. And then it says what's the remainder when you divide m by 15? So essentially what we need to do is we need to express ms in terms of 15p plus r, where r has to be, of course, less than 15. That's the constraint that we have. So how given the information, what can we express m as? We can express m as 30 multiplied by 8.2, which means 30 multiplied by 8 plus 30 multiplied by 0.2. All right. So what can we say about this term over here? This term is divisible by 15. Why? Because 30 is divisible by 15. All right. So and to be more specific, we can really take 15 out, and then you get a remainder as 2, uh, as 6. So the answer is choice C. Raha says, why can't we write this is 246? And Raha, yes, you can do the math in this question, but the reason we want you to follow this approach is because, hey, you're not here to get to a Q40, you're here to get to a Q50, and the questions that you'd get when you get to a Q50, you use the same method, but you won't be able to do the math over there. Okay. The idea is to use logic and not as much of the math. The moment you start using logic is when you start getting to that Q49 score or Q50 score or Q51 score. So Raz, does that answer your question? But good question. I mean, I'm glad you asked this question. All right. So we're going to solve the next question. Thank you very much. Let's get to broadcast results once again. And the nice thing about these questions, we understand learning something different is challenging. Your brain always questions, and this is that questioning part that makes us human, that makes us move forward, progress. So bring those questions in, but word them properly so that we are able to give good answers to those questions. Okay, I'm going to remove broadcast results and I'm going to show the next question. Here's your next. About half of you are done. All right, last 10 seconds. 5, 4, 3, 2, and 1. Now, before I'm going to end the poll, but before I broadcast the results, how many of you did the math to solve these questions, to solve this question? Actually multiplied, calculated the value of m as, 15 times 8.2, got to whatever number you'd get to, like 126, and then, divided that by 30, or 123, sorry, and divided that by 30. If you did the math while solving this question, you are not solving the question the right way. You will face trouble as we increase the difficulty level. So please don't do the math while solving this question. Use the method, and you'd get to know why that is the case. So again, the same concept that we are showing. Look at the question statement. It says, what is the remainder when m is divided by 30? Which means we need to express m in the form of 30p plus r. How many of you understand this concept? That you need to express m in terms of 30p plus r. All right. If you don't understand this concept, then this is something which I think, say, go back to the course. This webinar is probably going to start to get too advanced for you. But if you understand this concept, that's all that you need to know. Okay. So, but what's given to us? We're given to us that m divided by 15 gives us this decimal 8.2, which means that m can be expressed as 15 times 8.2. That's basically what we're doing. We just took 15 to the other side, which means when you visualize this, m can be expressed as 15 times 8 plus 15 times 0.2 as a sum of these two terms. Okay, we just opened up 8.2 as 8 plus 0.2. That's all that we did over here. Now, when we visualize this, what we are really saying is, let's kind of look at, let's call these terms 1, and let's call this term as 2. Oh, sorry, let me just write 2 over here. So let's call this 2, let's call this 1. Okay. So now, does the term 1 when divided by 30 leave any remainder? When 1's divided by 30, does it leave any remainder? 15 times 8, does it leave any remainder? No, it doesn't. How can we see this? We can see this, why? Because we can express 8 as 2 times 4, all right, and which means that 15 times 2 is 30. So m is 30 times 4 plus 3. 15 into 0.2 is 3. So this term over here does not leave any remainder overall when divided by 30. So the remainder, when you divide this by 30, this entire m by 30 is just this number over here. Why? Because 3 is indivisible by 30. How you guys did it? You guys got it right. But this is not the question that I want you to get right. I want you to get right the questions that are built on this principle, but in which you can't do math. Now let me just ask again. Is this method clear to you right now? Just look at it once more, because as we move on to the next question, I want more and more of you to start using this method. Okay. All right. So let's move forward. And we are going to use a very similar expression, but we're going to make it slightly more complex this time. And again, before we do that, let's kind of look at the answer choices. And I want you to select still solving. All right, good. Let me Remove broadcast results. Let me share the next question. Question, solve using the same method, but you'd have to use you'd have to just extend it slightly, but it's essentially the same approach. So solve using the same method. All right, 70% of the class is done. I'm going to give you another 30 seconds. I want you to follow. All right, 5, 4, 3, 2, and 1. Okay, I got a few questions on the Q&A part, and I could really see that you were beginning to apply that method. That was really nice. So, what's the problem here? We are given that m by 15 is 9.2. Okay, we want to figure out what's the remainder when you divide m by 30. Again, what we have to do is express m as 30p plus r. All right, where p is the principal or quotient and r is the remainder. Okay, and remember r has to be less than 30. So that's what we look for. All right, so let's kind of look at what we are given. We are given that m by 15 is 9.2, which means we can express m as 15 times 9 plus 15 times 0.2. All right, it's fairly simple. You guys saw that we did that last time, and we're going to really now elaborate this even further. We're going to visualize this further. But so far, are you guys with me when I do this? All right, perfect. Now we really say, hey, how can we break this number 9? And we say we can break it by 8 plus 1. So m can be visualized as 15 times 8 plus 1 plus 15 times 0.2, which is 3 over here. Okay. And so you guys with me so far? So can you see this step as well? All right. Thank you very much. All right, which means 15 times 8 plus 15 times 1 plus 3. What is 3? Again, remember, it's 15 times 0.2 that we got from here. Now, what we know is 15 times 8 is divisible by 30. 15 times 1 is not divisible by 30. And 3 again is not divisible by 30. So this is a term that's divisible by 30. But these two terms are not divisible by 30. These two ones are not divisible by 30. Let me actually do Control Z. Let's see, let's do undo. So we know, actually, let me get the annotations again. We know this term is divisible by 30 and these two terms are not divisible by 30 over here. 15 times 1 and 15 times 3. And so what we say is, hey, the remainder that you get is 18. And Avika, yes, you're absolutely right. You can really combine 1 and 0.2 together, and then you get the same answer. But yes, you'll be using the same method. So the correct answer is choice E, which 65% of you got it correct. In GMAT, how complex can decimals get? I think this is just about as complex as decimals would get. Again, remember that the GMAT doesn't want you to do the math, Rahas. It wants you to use your brain in a logical fashion. Why? Because it's about splitting problems or dividing problem into solvable parts. Because in real life, in business, that's what you do. You divide problems into solvable parts. Okay. So this was third question over here. And so what did we just do? We actually just looked at this one concept in which we said that that dividend is nothing but divisor multiplied by quotient plus remainder. And we applied this concept on 3 different questions, and we kind of increased the difficulty level of questions as we went on from one question to the other, but it was still the same concept. In the first question, we were given that m's 30 times 8.2, and we needed to find the remainder when m's divided by 15. In the second question, we reversed this. We were given m as 15 times 8.2. We had to find the remainder when m's divided by 30. In the third question, we were given that m is 15 times 9.2, and we had to find the remainder when m is divided by 30. And again, same concept, just in progressive difficulty overall. If you have that clarity of concept, if you have a structured thought process into applying this concept, solving these questions is fairly easy. And I could see that for many of you, you guys started to imbibe this process, which was for me very heartening. Now let's go forward and do this to 700 level questions. So this is where we start to take things in our stride. But before I do that, I want to ask this question. Are you guys, and I'm going to reset my yes no poll over here at the bottom right hand corner, 100% or 200% confident with this concept that dividend is divisor times quotient plus remainder? 90% of you seem to be. That's really good. I'm really happy. Others who are not, just remember this. Maybe once I share the PDF, solve these questions once again, maybe take some numbers, but all you need is just a session to get through this concept and solve the most challenging questions that you're going to get on this one. Okay. Because we're going to build upon this understanding, and so I'm not going to give you questions. I'm going to extend this concept slightly more before we solve the next set of questions. So we're going to look at 2 different cases over here, which is what we call as adding and multiplying remainders. So what is the remainder so we're going to take this case. So what is the remainder when you add 31 plus 43 and you divide it by 7? The answer is 4. Let's kind of see how can we get that. How can we get that? There are 2 ways of doing it. One is that you add 31 and 43, you get 74, you divide that by 7 and you get the remainder, which is 4. The second is you actually divide 31 by 7, you divide 43 by 7, you get their subsequent remainders and you add the 2 remainders and you really say, hey man, these remainders are still less than 7, so 4 is my remainder. I'm going to pause for a couple of seconds. So is sequence 2 over here, which is this piece, is that clear? Select yes if sequence 2 is clear. Now, why is sequence 2 more interesting? Because sequence 2 simplifies the math for us. It allows us to really look at big numbers and divide them into chunks. And when questions become more complex, as you're going to see that they would, you're going to see sequence 2 become more and more useful. And I'm going to prove that. But when numbers are simple, either one is good. But when numbers get more complex, then things become slightly difficult. Raha says, does it work for the minus sign as well? We're going to come to that. But yes, it does in many ways. So now that's a case of addition of two numbers. Now let's talk about multiplication of two numbers, which is when the math starts to become slightly more complex. Okay. Again, what's the remainder when 31 times 43 is divided by 7? The answer is 3. Let's kind of see how we get that. Again, we can do the same things. What can we do? The first is we can multiply this. Multiplying is a bit of a chore, not as complex, but it is. You get 1333. Okay. And you divide 1333 by 7, you get the remainder as 3. But then the second way to do this is you take each of these individual numbers and you divide them by 7 and you get the remainder. 31 by 7 gets you 3, 43 by 7 gets you 1. Why? Because 42 neatly divides and you get 1, and you multiply the two remainders. So 3 times 1 is 3, and you get the same answer. And you say 3 is less than 7, so it has to be 1. If the product of the remainder is greater than 7, then you actually subtract 7 from it. You actually divide that product by 7, and then you get whatever that remainder is. Good question, Avika. So if instead of this, if these were, if the individual remainders over here were, let's say 6 and 3, you would get 6 times 3 as 18, and you'd do 18 by 7, and the remainder would be 4. Oh, okay, but first of all, is the second method clear? I'm going to justify why the second method works. For some of you are wondering why does this work, but is the method clear in sequence 2? All right, perfect. So this is what we call as adding and multiplying remainders. Okay, and we're going to really justify why this works. But before we get to justification of why this works, what I want to do is I want to make sure that you guys can see the methods. When it's about adding two numbers, you divide, you get the remainders for the numbers individually, and you add them up, and if the sum is less than the divisor, then that's your remainder. When it's about multiplication of two numbers, then you divide each one of the numbers by divisor, get their individual remainders, and then you multiply them. If the product is less than the divisor, then that's your remainder. Okay. Again, the principle that we are using is the same principle. Okay. So how does this rationale works? So again, this is the same thing. We're going to really prove why does this work overall. So how can you express 31? 31 can be expressed as 7 times 4, so a product of the divisor times something else plus 3, which means, and then 43 can be expressed as 7 times 6 plus 1, which means when you do 31 plus 43, what you're doing is you're doing 7 times 4 plus 3 and plus 7 times 6 plus 1. I want you guys to focus on this expression. Can everyone understand how we got to this expression? All right. It seems everyone gets this. That's wonderful. All right. So remember, we have to divide this by 7. So we write this form in the equation. 7 times 4 plus 6. How did we get 4 plus 6? We combined this term and we combined this term. So we took 7 common, so it gave us 4 plus 6, and then we got 3 plus 1 by combining. Let me just get the blue color by combining this term. Well, I couldn't get the blue color. Let me get the one that I can get, a red color, by combining this term as well as this term. That's how we got this. All right. So which means 7 times 4 plus 6 plus 4. This term doesn't leave any remainder over here, which means our remainder is 4. Okay. You guys understand why this works? Perfect. And I see some of you are posting more complex questions. Just wait for a couple of more examples and you'd see those complex questions being solved. All right, so this was the addition part. Let's kind of move on to the multiplication part now. And let's see, why does this part work? Which part? That you can multiply the individual remainders to get the overall remainder. Let's see, why does this work? Okay, again, we're going to take the same example, 31 by 7, 31 multiplied by 43 divided by 7. That's the remainder. We want to find the remainder for this expression overall. Okay. So I'm going to move this pole out. So what do? We express 31 as 7 times 4 plus 3. Again, the same thing. 43 as 7 times 6 plus 1, which means the entire expression becomes this. Now remember, we have a multiplication sign over here. So 31 times 43 becomes this. Does everyone get this expression? Does everyone get this expression? 31 times 43 is 7 times 4 plus 3 multiplied by 7 times 6 plus 1. This is the key expression, so I'm going to pause on this for a moment. Okay, I want to see a few more yeses, please. If I may. I have many more students in this webinar. All right, thank you. So when you simplify it, you get this. You get 7 times 4 times 7 times 6. So you actually multiply terms over here. So this first term is a multiplication of this with this over here. Then you get 3 times 7 times 6. So you multiply 3 divided by the first term over here. Then you get 7 times 4 times 1, which is this. And then in the end, you get 3 times 1. Now, I'm going to pause again. I'm going to ask a yes no poll. Can you guys, now this may not look simple, but this is a simplification, and can you guys understand this simplification? Now, when you do this, each of these terms over here is divisible by 7, barring the last term. So this term is divisible by 7, this term is divisible by 7, this term is divisible by 7, which means these three terms do not leave any remainder. The only term that leaves a remainder is this term over here, 3 times 1, which is why the remainder is 3 times 1. Again, it's the same equation. All we all we are doing is expressing it in the form of 7 times b plus r, and that r is 3. Do you guys understand this? Take a moment to write this down. When you're adding two numbers, you can divide each one of them by the same divisor and add the remainders. When you're multiplying two numbers, you can again multiply the remainders that each of the two numbers leave, and then if that remainder is less than the divisor, then that's your remainder. Okay, we're going to start using this, and we're going to start with a very, very simple thing. But before we do that, I want to ask ourselves a question. How are we feeling so far? How are we feeling? All right. Great, good, fantastic, better, enlightened. Good. I like those answers. Okay. The questions seem easier now. That's good. I like that. Now, let's move forward. And we're going to, again, play the same game. You have 5 answer choices. You have to select still solving. We're going to apply these concepts now, along with some of the concepts that we had from before. Let's get to 40 people saying still solving. 37, 40. Good. I'm going to remove broadcast results, get to the first question. All right. Last 5 seconds. I think pretty much everyone has answered this. 5, 4, 3, 2, and 1. So I'm going to put in a short answer poll over here, and I'm just going to ask a very simple question. And this is where we kind of, when we get to our preconceived notions actually kill some of those, some of the that thing, some of the obvious things that we need to see. What's the remainder when you divide 24 to the power 3 by 3? What is the remainder? 0, right? 0. 24 divided by 3 gives you 0 as remainder, not 1. Remember, 0. So, and what's 0 multiplied by anything? That's also 0. So, if I end the poll and broadcast the results, so many of you chose C. Where did you make a mistake? So many of you chose 2. Where did you make a mistake? Guys, I have... Yeah, but why did you did not look at 24 multiplied by 3? That's 0. And then anything multiplied by 0 in the multiplication of 2 remainders. So some of you, and this is very nice. This is where the wisdom of a group tells us where we falter. Okay. Some of you said, man, this expression is really complex. I don't know how to go about doing this. And let me guess. And some of you really kind of did not worry about 24 by 3 is 0. So everything has to be 0 given the formula. So I'm going to really just look at how we go about solving this. And this is a classic case where there is really no math required beyond 24 by 3 to get to the answer. Okay, so you look at this expression and you said there are powers, but let me just focus on individual numbers. And he said 24 is completely divisible by 3. So anything multiplied by 24 has to be divisible by 3. So the remainder has to be 0. That's a very simple thing. And again, the thing that I want to make sure is, we told you the method, but again, you can stick to your basic understanding. That doesn't go away. The method is to make you more efficient. That's all there is. Now, even if you use the method, you basically said, let me just do 24 by 3 first, and then worry about 35, because 24 seems to be divisible by 3. You got that 0 multiplied by anything, because when you have a product of two numbers, you basically multiply the remainder of one with the remainder of the other, and the remainder of my first number is 0, which means the product has to be 0. Again, either way you saw, you'd get the answer as 0. So again, don't forget the basic foundation of it as you learn new things. That's very important. But now we're going to start to have some more fun. We're going to start to really apply these concepts over here. So let's select still solving. And these are 700 level questions. I mean, statistically, it's been proven these are 700 level questions. But what I want to prove to you is, even though there are 700 level questions, even though half the class was below Q40, which is at around 40 or 35th percentile or so, the math in this was fairly easy. Okay, so again, all you need to do is keep your eyes open. Have the confidence when you see complex things. If you have the confidence, if you tell yourself, I know everything that I need to solve this question, chances are more often than not, you'd be able to solve 700 level questions. Okay, and again, take a step back, take a deep breath, tell yourself you know everything that you need to solve the next question. The next question is just trying to scare you. As long as you're not scared, you'd be able to solve this. You have the tools to solve that question. So let's do that. Here is my next question. Here is the question. All right, everyone's done. That is so great. And what makes me even more happy, and I want to actually show my video, is that you guys got it right. Let me end the poll. 75% of you got to the correct answer. Nothing makes me more happy. So what clicked here? What clicked here? From 40% accuracy in the last question to 76% accuracy here, what made the difference? Just the basic concept. Just using the concept. Okay, good. Good. All right, I am so glad that you guys were able to do this. Again, it's the confidence more than anything. Tell yourself you know this. Okay. And if you're lost, let's kind of see. I'm going to show the solution. Figure out. One thing that if we start to worry, then our mind stops looking at reasoning, and our mind just its ability to reason out goes down. So even if you made a mistake, those 23-24% of you who made a mistake over here, first of all, stop worrying, because once you stop, tell yourself you will be able to solve this, because once you stop worrying, then you start focusing on the solution, which is what I'm going to show next. Okay, take a deep breath, take a sip of water. I'm going to take a sip of water because I'm thirsty. And the solution is for the 24% of you, because we're going to be able to solve another question after this. Okay, so how can we consider this expression? We can consider this expression as 24 times 38 multiplied by 24 times 38 multiplied by 24 times 38. Okay, so we can calculate the remainder for each term, and all the remainders can be multiplied. Okay, so essentially, if you split it up, we say 25 by 3 times 38 by 3. What's the remainder of 25 by 3? 25 by 3 is the remainder is 1 over here. Why? Because 25 can be written as 24 plus 1, and 38 can be written as 36 plus 2. So the remainder for 38 by 3 is 2 over here. So it's 1 multiplied by 2 whole cube, which means 2 cube, you get 8 over here. And you get the answer as 8. No, you get the intermediate answer as 8, not the final answer. So how many of you were able to get to 8? Select yes. But then when you get to 8, you really say, hey, but the remainder has to be less than the divisor. And the divisor over here is 3. So what I do, I divide 8 by 3. I express 8 as 3 multiplied by 2 plus 2, which means I get the answer as 2. And which is your choice C, which most of you got. Okay, so now we're going to solve, I think, one more question. All right, or we're going to actually do an overview of this. So what did we do going forward over here? Why are my slides not going forward? Just 1 second, guys. I'm going to pause this, figure out why my slides are not going forward. Yes, now they're going forward. So the thing that I want to prove over here is that calculations, you don't need to resort to calculations. If you know this, if you just simply express the dividend as divisor into quotient plus remainder, that's very, very important. Again, sum of two numbers is divided by a number. You can add their individual remainders. Product of two numbers, you can get their individual remainders and multiply them, and as long as that remaining the product is less than the divisor, that's the remainder. Otherwise, whatever is left, you actually divide this by the divisor as well. Okay, so that's what we've learned so far. Take a step back, make note of this, because now we're going to actually go one level forward. We're going to go into the concept of what we call as negative remainders. We're going to go into the concept of negative remainders. It's a very, very useful concept. Okay, I'm going to give you guys another 5 to 10 seconds to take a step back, soak this in, and so that you're ready for that next step, which is negative remainders. Three, two, and one. So again, the basic concept for negative remainders is still the same, where your dividend is same as divider times quotient plus remainder. That is still the core concept. We're not forgetting that. The remainder is always less than the divisor A, and B, the second constraint is, I'm going to really do it this way so you can really see that remainder has to be greater than or equal to 0, which means it has to be positive. Okay. So again, you can say 5 divided by 2 is, you can express 5 as 2 times 2 plus 1. 8 divided by 3, you can express 8 as 3 times 2, so plus 1. Okay, let me actually pause my video so the voice remains. So we reduce the bandwidth usage. Hopefully the voice is better now. And I'm gonna just get my mic closer so the voice is a bit more consistent. So so that's one way of doing it. Okay. So but what if we actually did the same thing and said, hey, how about we write 5 as 2 times 3 minus 1, okay, and 8 as 3 times 3 minus 1. So 5 as 6 minus 1, and 8 as 9 minus 1. And that's also correct, right? I mean, 5 is 6 minus 1 and 8 is 3 times 3 minus 1, and it's still in form of 3. And then we need to do this. This is what we call as negative remainders. And why do we need to use negative remainders? And I know people don't like negative numbers, but there are scenarios in which negative remainders allow us to process things better. Okay. So, and especially when you have to apply constraints. So, but remember, what is our constraint here? That let me get the right annotation, that a remainder always has to be positive and it always has to be greater than the divisor. But so even when you get a negative remainder, you have to convert it to a positive remainder, because that's a remainder is always positive. Okay. So how do we use the concept of negative remainder to get a positive remainder? Let's kind of look at this. We're going to use these equations. Which equation? 5 is 2 times 3 minus 1. So again, I'm going to slow down. I want you to increase your focus over here. And this may seem unnecessary given what we have studied, but trust me, be with me for the next 2 minutes or so, and then as we apply this, you'll get to see why learning this becomes important. Okay, so 5 was 2 times 3 minus 1, and what we did was we had to really figure out what is the remainder when you divide 5 by 2. So what we did was we added plus 2 and minus 2. So we added a 0 in a sense over here. So over here we added plus 2 and minus 2. Everyone with me so far? Just this equation. All right, we just said 5 is 2 times 3 minus 1, and then we added a plus 2 and minus 2, okay, on the right hand side itself. Okay, now all we are doing is rearranging the terms. So we got the minus 2 closer, closer. So and okay, so we move this minus 2, and let me actually remove the annotation. What we did was we moved this minus 2 over here, we closer over here, we move this over here. This is why, where you get this over here, and then we moved this minus 1 to this position. That's all that we did, okay, to get this equation. So what we are able to simplify, 5 as 2 times 3 minus 1 and then you get this other piece over here. You guys with me in this equation? Take a look at it. I'm going real slow. Take a look at it. All I'm doing is I took 2 common. How I got 3 minus 1 is I took these 2 parts over here, these 2 parts, and I took 2 common, and you got 3 minus 1. Then I combined these 2 parts to get minus 1 plus 2. That's all there is, which means 2 times 2 plus 1, which is the same thing, and you get remainder as 1, which is kind of what we got over here if you think about it. This is how the concept of negative remainders work. You might still be thinking, why are we doing this? Again, just wait with me, but just learn this concept. What did we do over here? We started with expressing 5 as 2 times 3 minus 1, and then we added and subtracted the divisor over here. So if you remember, we added and subtracted the divisor, we rearranged the terms, and then we got to this. Now we're going to do the same thing with 8. 3 times 3 minus 1, then added and subtracted the divisor. Again, I just want to prove that we get to the same remainder. Then we rearrange the terms once again. So we got this 3 over here. We got this 3, this minus 3, we got this over here. Okay, and then we just pushed everything back. We said 3 times 3 minus 1, and then minus 1 plus 3, which again 3 times 3 plus 2, which is exactly the same thing that we got over here and over here. And we know this term is divisible, so plus this term is divisible, so plus 2 is the remainder. Okay. Okay, so this is the concept of negative remainders. We are going to use this concept in the next couple of questions. Okay. Now, as you get to the next couple of questions, again, you know everything. So all you have to do is, instead of expressing the dividend as divisor time question plus a number, what you're going to find is that it's going to be easier to really express 8, the equivalent of 8, as 3 times 3 minus 1 rather than 3 times 2 plus 2. That's just because of the nature of the questions. So that's all that we're going to do. But before we do that, still solving. And again, some of you still have doubts, and completely understandable. Just trust me for the next 15 minutes, and things would be as clear in your mind about negative remainders as they were about the positive remainders. So just be with me. Okay, still solving, and I want to get at least 35 people selecting still solving, guys. We want to move forward. We are already hitting that 90-minute mark with this session. So yeah, good. Here is the next question. Here's the next question. few minutes. All right, 70% of you are done. Actually, 80% of you are done. So another 5 to 7 seconds. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. 60. This is a 700 level question. 62% of you got it right. And I know you can get it right through the concept of positive remainders as well, but I want to show you how to do this much more simply using the concept of negative remainders. So what do we have to get? We have to find the remainder of the scary product of the scary numbers plus 17 to the power 7 divided by 3. Okay, so what do? We really just say, hey, remainder of sum of two numbers is their individual remainders, sum of their individual remainders. We know that piece already. Okay, how many of you did this? How many of you actually did this simplification? Let me clear this up. How many of you did this simplification? All right, I am so glad to see so many of you doing this simplification. Okay, now this first term, the remainder for that is 0. So we already know that. Why? Because we know 24 is divisible by 3. We did that in our, I think, 3 questions ago. And so we said, so the remainder has to be what 7 to the power 7 by 3 does. Now you can express 17 as 15 plus 2 and then take it to 2 to the power 7. That's one way of doing it, but that's not how I want you to do it. I want to express 17 as 3 times 6 minus 1. Okay, and I want to get the remainder for that. All right. Um, so why? Because 1 has an easier processing than 2. Because when we do that, everything has to be to the power of 1 only. So what is the remainder of 3 times 6 minus 1? This because this is divisible by 3, it's minus 1 to the power 7. So it's minus 1. Now minus 1 is a negative number, so that can't be a remainder. So what do? We actually convert it to a positive remainder by adding 3 to it, and you get your answer as plus 2, which you guys got it. A lot of you did it using positive remainder, but yeah. And Jala says yes, you did that. You actually did the split over here, and that's one way of getting it. But what you're going to find is once you get the concept of negative remainder, things become a lot easier. Okay, I want to make sure that you get that concept. Why not simplify? Again, you guys are asking why not simplify it that way, and I understand that you just learned positive remainder, you have that eureka moment, and you can do it. It'll get the same answer to you. This one just is easier math. Kalpit says, does the power of number not impact the remainder? It does, Kalpit, and you're going to see that in the next question. But when the power is 1, then in that case 1 to the power anything is 1 itself. It's plus 1 or minus 1, depending on whether you're doing minus 1 to that power or you're doing plus 1 to that power. Okay, we're going to solve the next question, and then this time I'll give you extra time, but try and apply the concept of negative remainders, please. Okay, try and apply the concept, and I want you to select still solving, because with the concept of negative remainders the answer is going to be very, very simple. I'm going to remove broadcast results. Here is the next question. Here's the next question. 80% of the class is done, guys. Let's get those answers in. 3, 2, 1. We end the poll. 700 level question. 82% of you got it right. That is fantastic. Um, that's really great. So what are we doing over here? We have to figure out, again, the same expression, what remainder does it leave when you divide it by 6. We follow the same approach. We say, hey, 24 is divisible by 6, so this one has 0 remainder. So essentially we have to figure out what's 17 raised to the power 7 divided by 6. Now that's a difficult math if you do positive remainder. Why? Because 5 to the power 7 is not so easy to calculate. But if you express 17 as 6 times 3 minus 1, things start to become very easy. You still get minus 1 to the power 7. Again, it can't be negative, so you add 6 to it and you get the answer as 5. And Rohan says, does this help? First of all, can you see the utility of negative remainder here? And Rohan, good question. Rohan says, what if it wasn't one? What if you couldn't do one way or the other? The GMAT won't do that, throw that at you. Remember this, always trust the test maker, because there's no, on the test, you're not being evaluated on your ability to do the math. You're evaluated on your ability to follow a process. Okay. And this is where following the process becomes very simple. Excuse me. So, excuse me, let me get some water. Yeah. So we are sometimes negative remainders can help simplify calculations, and again, it's really important to make sure that you understand this concept, you know how to apply this concept. And some of you are still fussy about it. You will get the recording of this. You will get the PDF. Just work on it. Spend 10 minutes on it, and trust me, you will get it, because each one of you is smart. Okay. So it's okay when some remainders become come negative. Just you have to convert them to a positive remainder. And how do you do that? You just add divisor to that negative remainder. Okay, that's all there is to it. Now let's get to those holy grail. Let's get to that holy grail over here. I want you to solve these questions that we had. And question 8. You clear all answers. I have your accuracy earlier. I want you to select still solving. Let me broadcast results. I can see 35 people saying still solving. Okay, good. I'm going to remove broadcast results. Here is your first question. Remember, you saw the same question early on. So I want to see the improvement. All right, about 82% of you are done. Let's get those answers in. 3, 2, and 1. I'm going to end the poll. I'm going to broadcast the results. I see people in, I can divide people in three categories over here. Okay. Those who chose choice A, and a number of you chose choice A right away, are the ones who actually took the concepts that we learned so far and 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 applied it in a truly in a diligent fashion. And most of you who chose choice A, which is the correct choice over here, um, uh, uh, were able to do it within the first 40 seconds or so. Okay. Those of you who chose choice C were did understand the prior concept, but still were too stuck in the math of it rather than the logic of it, and essentially hence chose choice C, where he said both statements are required. And those who uh, chose choice D, I want to figure out. Actually, I don't know why you chose choice D, but I can make good judgments about choices A and choice C. And if you chose choice E, again, I want to figure out why you chose choice C. But let's kind of see why choice A is correct. And I want you to critically evaluate yourself and tell me where you made a mistake. Those of you, the half of you who made a mistake. But so let's see what's given to us. What the question is asking is, what is the remainder? So we need to figure out the exact value of the remainder when a positive integer p is divided by a positive integer m, where m is greater than 1. So m can be 2, m can be 3, m can be 4. Now, the first thing that's really important in a data sufficiency question is that even before you go and read the statements, the original question stem, when you read, you should kind of have a visualization happening in your mind itself. Now, why do we say data sufficiency questions are more difficult? Then, or why do people find data sufficiency questions more difficult? Because people like not working with numbers. That visualization piece as a habit is not a very natural thing that you have. People who get to that Q49, Q50, Q51 actually build that habit. They know just as much math as you do, or you know just as much math as they do. It's just that they know how to visualize this, and which is what we want to inculcate over here. Okay, so you have to visualize m as 2, 3, and 4, and we have to figure out what is the remainder when you divide p divided by m, which means p should be expressible as, you know, m times k plus r, where r is a remainder. That visualization needs to happen even before you start reading the statements. Why? Because just as in verbal, once you start reading the answer choices, your mind gets polluted, and then it becomes difficult to visualize this. So, what's the question statement analysis? Given that m is greater than 1 and m is positive, we have to find the remainder when m divides p. Okay, let's look at statement 1. Uh, 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 Statement 1 is saying that we can express p as m plus 1 raised to the power 8, which means p can be expressed as m plus 1 multiplied by m plus 1 multiplied by m plus 1 8 times. Okay, so what does p by m become? P by m becomes m plus 1 multiplied by 8 divided by m. Okay, you can take m inside, and remember the term we said, when you have a product of numbers multiplied by divided by a certain number, you actually can divide each one of those individual numbers by the same divisor. That's the same principle that we are using over here. The principle that we just learned for positive remainders. That's why we caught m inside, and because m divided by m leaves no remainder, this means the remainder would be 1 divided by 8, which means the answer would be 1. Half of you did not get this. Where did you falter? You tried to do the math. You try to do the math. You were really focused on numbers. Okay. You thought M was needed. Yes. And again, that's where, again, you have to trust the test maker and you have to trust yourself. Okay. For those of you already saying, how did we get M inside? Remember, what did we say? If you have a product of two numbers and you divide that by, and you really want to figure out what's the remainder for product of two numbers divided by a divisor, then you can divide each one of those numbers individually by the same divisor and you can get their remainder. That's the same principle that we are using over here. In this case, P is expressed as a product of 8 numbers, m plus 1. Each one of those numbers is m plus 1. So as long as we can get the remainder for each one of them individually, we can multiply and add those remainders and get the answer, which is kind of what we did over here. Okay. Now let's look at choice option 2 or statement 2. Sorry, not option 2. All right. So after you do this, you say A or D are the options. Then you say M is equal to 8. Okay, you got a value of M. Individually, does that tell you anything about what would be the remainder? No, because we don't know what P is. Hence, because there's no information about P, we can say that statement 2 is not sufficient. Okay. Again, fairly simple question. We just use the same concept that we used in the prior question. Okay. Now, the next question is also scary looking. The next question also requires that you do simplification and then you do understand what this statement means before you start looking at the next ones. Because trust me, the moment you start looking at statement 1, you are going to go bonkers if you don't do that processing. Okay, so let's get to question number 9, and I want to see if we can do this. Now these are Q50, Q51 questions. I will tell you that these are difficult questions. Okay, so even at 700 level, we are now hitting that 750 level question right now. So these are difficult questions, but I want to make sure that you understand that they don't require difficult math. All right, still solving. 35 people stay still solving, and then you're gonna see the question. I know you want to go, so do I. Uh, it's 10 a.m. my time. I need to go have my breakfast as well. Perfect. All right, here is the question. Process the original statement first. All right, 80% of you are done. I'm going to give you another 10 seconds. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. We still have a split jury. We got about 30% of you answered this correctly. It's a difficult question. It actually uses the concept of negative remainders, which we just learned. So again, I know it's been, we're 2 hours into the session. We had a lot of fun. Now we're moving that to that next level, which is the Q50, Q51 level, and you are getting it, but you're facing difficulty solving it. So just don't get disheartened. Let's kind of look at this. What I want to take away from this is that, hey, where is it that you need to work next upon when you are at that Q48, Q49 level with regards to just this topic? What do you need to get to that Q50 level? So let's see what's given to us. Again, these are scary expressions. N is a positive integer, and we need to figure out what's the remainder when 38 to the power n to the power 2. So 38 to the power n square is divided by 13. Okay, so let's understand the question statement. Let's not read statement 1, statement 2. Okay, so let's kind of look at this. We have to figure out the remainder of 38 to the power n square, and we know that n is a positive integer. Okay, so let's kind of put the same thing over here. We do 38 by 13 to the power n square. The same principle. Product of remainder of product of two numbers is their product of their individual remainders. That's the same concept that we learned that we're going to apply over here. So we can express 38 as 13 times 3 minus 1. Okay. You can also do that 13 times 2 plus 12, but that's really complex. So what this means, 13 times t minus 1 would leave a remainder of minus 1 to the power n square. Remember the concept of negative remainders? We said that. How many of you remember can get this part using the concept of negative remainders? Okay. Now, 92% of you do, and 92% of you know all the math that you need to know to solve this question. Everything else is just simply logic. So this means if n is odd, okay, which is case 1, which is n is odd. If n is odd, this number is going to be negative, which means that we have to really add 13 to it. If n is even, this number is going to be positive. Okay, so if n is odd, the remainder is 12. If n is even, the remainder is plus 1. That's what we need to figure out. Is n odd or is n even? How many of you are with me right now? All right, close to 90% of you. Those of you who are not with me right now, all we are doing is applying the concept of negative remainders. So post this session, take the PDF, download the PDF, go through the concept of negative remainders, and you will get it. So spend just 30 minutes on this. That's all that I would ask from you. Okay, so let's analyze statement 1. Statement 1 says that n leaves no remainder when divided by 4, which means n is 4k plus 0, which means n is even. It tells us that n is even, which means the remainder is plus 1, and statement 1 is enough. Okay, statement 2 really says n is a prime number, a square root of n. So statement 2 says square root is only divisible, square root of n is divisible by 1 and the number itself, which means that n is a square of a prime number. Now a prime number, a square of a prime number could be even or it could be odd, because 2 square is 4, 3 square is 9, 5 square is 25. So n could be either even or odd. Does it give us a definitive answer as to what the remainder would be? No, it doesn't. So statement 2 is not sufficient, which means my answer is choice A. Okay. How many of you with me right now? All right, so the math here wasn't challenging as long as you understood the concept of remainders. We did all this math that we have done so far. Okay. So let's kind of see what needs to be done to be able to get to this point where you can get these questions. I think the key thing is hopefully this session gave you the right foundation in divisibility and remainders, A, and B, it told you that essentially GMAT quant is not about math. GMAT quant is about logic. And even when you know the math, it's about this logic that you need to master. So, so I want to tell you people, even if you know the math, you need to focus on tackling questions this way to get to a Q50, Q51 or so. And here's an example of someone who actually did well in math, struggled on the GMAT, as the person started to recognize that he had to focus more on visualization, more on applying logic, that person was able to move beyond that Q48 and get to that Q51. And that's really important because a lot of you were able to do problem solving with 80% accuracy, the same 700 level questions. It's the data sufficiency questions where you faltered on. Okay, and they were more about visualization than about doing math. In fact, even the problem solving questions were not about visualization, but data sufficiency took that visualization to a very different level. Then it's about people who are struggling with math. Here's an example of a guy called Leonardo. He was able to get to a Q45, but struggled beyond that. Again, he had the foundation. He knew that your dividend is equal to divisor times quotient plus remainder. But when it came to applying it on complex questions, he struggled. What helped him improve to a Q49? He actually made sure that he focused on logic. He made sure that he used data to figure out the areas that he needed to work on and build his confidence there. Because a lot of GMAT quant is about building that confidence, and then he did selective practice. Again, he got admitted to Stern, Tepper, as well as Wharton. He's in his second year at Wharton right now. As an example of a guy who improved from a Q30 to a Q45, again, a very similar story. He needed to work on a ton of stuff. Someone with a Q30 needs to start from the very foundation, and that's where the guy made sure that he tackled the right questions. He didn't go for difficult questions right away. He built his concepts on that 500 level question. Then he went on to the 600 level questions, and then moving forward. It's very tempting for us to move forward towards a 700 level question. That sounds sexy, but if you know you're not there, just spending time on it doesn't accelerate your learning path. It actually decelerates your learning. It lowers your confidence, and you saw what happens on GMAT Quant when you're not as confident. Okay. And here's an example of a guy, again, who went to Wharton, started at a Q38, and Wharton's a quant focused school, improved to a Q50, again, using a very similar process. Again, the one thing that he did was he kind of realized the areas he needed to work on, and he had target ability scores for number properties, for word problems, for geometry, for algebra, and so on and so forth. And he worked on them, eliminated his mistake till he hit those ability scores. So again, to ace GMAT Quant, what you need to focus on is learning and adopting good habits. The math is not what's stopping you from getting a Q49 or a Q50. It's A, your confidence, B, those habits that you need to build upon. Early on in this webinar, we saw there were questions that you could have done by just simply doing the math, but using logic allowed you to build on those good habits that allowed you to essentially solve more challenging questions later on. Build those habits. And to build those habits, try looking at the free trial, and if you like the free trial, go and upgrade to the paid part. because you would see that that you continue to build those habits, not just in this confinement of divisibility and remainders, but also in even odd primes and the other topics on GMAT quant. Good luck, and again, right after this, make sure you go through the free trial. Make sure you revise the question in the PDF. Spending that time would help cement this understanding. Let me share the PDF with you. And again, if I could get some feedback on the webinar, that would be wonderful. Ravi says, I want to start with the basic concepts. Will GMAT official guide help? Absolutely not. GMAT official guide is a practice resource. It's not a resource for learning concepts, especially if you want to start at basics. If you're at Q48, you want to go practice from GMAT official guide, be my friend, and that's perfect. But if you are at a Q41, Q35, you start practicing from GMAT official guide, more often than not, you're going to falter. If you are on a tablet, you're going to see that it's unsupported content. Unfortunately, Adobe Connect doesn't allow that. We're going to send the PDF and recording as well. So so yes, we're going to really do that. But if you are on a laptop or on a PC, you should be able to do this. Where do you start? We start using the e-GMAT course. We start from the very basics. The last question is in the PDF. I did not want to do this because I think I was overburdening you. It required revision of the concepts that we already have done. So yeah. So again, the solution is there. You should be able to follow it. And thank you for that takeaway that, apply the concept rather than do the math, Karan. That's really, really important. All right. With that, I want to thank everyone and wish you good luck. Bye bye and have a great day.